Oh, hello. Sorry that I, I needed a second to get set up. Okay, so today we're going to talk about maximizing, and in this case, minimizing an area of a given function. So let's get started here. 1 second. Okay, all set. So we're given a problem about a publishing company that wants to have a piece of paper that's printed that has 30 square inches of print. Okay, think about a piece of paper that you would normally use in your printer that you're writing an essay on or something. There are margins around the outside, and I know we only use 8.5 by 11 pieces of paper normally, but this case, this company over here that we're using wants to have the smallest piece of paper possible so that they can minimize their cost. Okay, because the more paper they waste, the more money they waste, and they don't want to waste any money. They want to actually make money as a company. So we're given constraints that it has to be 30 square inches of print, and the margins all around the print are 2 inches wide. Okay, so there are two things that we need to do. We need to first write an equation, because we can't solve anything without an equation, and then figure out what is going to make this the biggest, or what is the smallest amount of paper that we can use in order to get the best bang for our buck, basically. Okay, so we're going to start off by drawing a picture. So this publishing company has a piece of paper. So let's draw ourselves a piece of paper. I'm going to assume that it's rectangular. It could be square, but it's at least going to be a rectangle. Okay, and I have 30 square inches of print. So if you think about this as a piece of paper that you printed your essay on, this is where all of the text would be. There is 30 square inches of text inside here. Okay, and everywhere around we have 2-inch margins. Okay, 2 inches, 2 inches, 2 inches, 2 inches. And our paper was, let's see, X units wide, it said, and Y units tall. So it is defining the variables for us. X is the length of this paper, and Y is the height of this paper. Okay, how long, however you want to use the words to describe the dimensions of this paper. Okay, so there are two different areas that we're trying to talk about. Number one, the area of the paper. Okay, the actual paper that this stuff is being printed on. So that would be this. Here is one of those lengths. So the area of this paper is rectangular, so it's X times Y. So the area of a rectangle is the length times its width. So the piece of paper has an area of X times Y. So right now, the paper is a function of X and Y. Okay, so if we're going to express this paper as a function of just X, we're going to have to get rid of our Y value somewhere in the future. Okay, so we haven't used the other area problem yet either. So our other area that we're talking about is the area of the print. Okay, all the stuff that got printed on the inside here, there is also an area associated with that. So that happens to be 30 square inches. And it is a rectangular area also, so that's made up of this length and this width, or this height. So the tricky part is, what is this length? So this is a horizontal length, so it has to be something in terms of X. So this whole entire thing was X, but then I subtracted 2 inches from this side, and I subtracted 2 inches from this side. So this length would be whatever X is, the whole entire piece of paper, minus 4 inches. Okay, 2 inches from the right margin, 2 inches from the left margin. So whatever my width, my length happens to be, I subtract 4 inches from it, and I can get the length of the print. Okay, similarly for the Y value, for this, okay, the height of this printed area, okay, normally the whole entire thing would be Y, but then I subtract off 2 inches from the top margin, and I also have to subtract off 2 inches from the bottom margin. So the Y, or the height of this, is going to be the Y value minus 4 also. Okay. So here I have two different area equations. I have the area of the paper, which is the outside x times the outside y, and I also have the area of the printed stuff on the inside, which is the outside length minus 4 times the outside height minus 4. So if we want to express the area up here, that means we need to substitute. Okay, we have to use the algebraic property of substitution. So we have to substitute in for y, which means down here we have to solve this equation for y, because you can only substitute when we have equality. So we have to get this as y equals in order for us to be able to substitute it up there. Okay, and that's what makes these problems hard, is that you have to come up with your own area equations, know what to get rid of, and know what to solve for. So we're going to solve this area of print equation for y. Okay, remember what we're trying to do. We're trying to find an equation for the area of this page as a function of x. So this equation with just x as the variable. We have x and y. We're trying to have it be just x. So let's bring it down here and we'll work a little cleaner. 30 equals x minus 4 times y minus 4. So because this is multiplication, this thing times that thing, I am able to divide both sides by x minus 4. Okay, so that gets rid of this multiplication piece. So 30 over x minus 4 now equals just y minus 4. Okay, much cleaner. So now we have to get rid of this plus minus 4, so we'll add 4 to both sides. Now remember, we're not adding 4 to the top, we're not adding 4 to the bottom. We are adding 4 to this rational equation of 30 over x minus 4. So 30 over x minus 4 plus 4 is the y value. We do not add to the top, we do not add to the bottom. We only add if we have like denominators, and this has a denominator of 1, so we don't just combine these two at face value. Okay, but I have solved my equation for y. And you say, yeah, big deal, so what? Well, so what? Now I can substitute it back into here. Okay, so going back to our first question, we want to express the area as a function of just x. So here, area equals x times y. We just determined that y was 64 over x minus 4 plus 4. So now the area is x times 64 divided by x minus 4 plus 4. Okay, this is an area formula with x as the only variable. Notice 64 is a constant, plus 4 is a constant, minus 4 is a constant. Our only variable on this side of the equation is x. Okay, so I'm going to do two other things. I'm going to distribute to simplify a little bit before we plug this into our calculator. So this is 64x over x minus 4 plus 4x. Okay, and I'm not really satisfied with this. Your teacher might be, and this might be okay. Your calculator actually likes this just fine. But I'm going to go a little bit further and simplify this down. So if I want to add these two things together, I need to make this one into a fraction that has the same denominator as this one. So I'm going to multiply by x minus 4 over x minus 4. Okay, I'm multiplying by 1, so mathematically I'm not really changing this. It's only going to look different. So 64x over x minus 4 plus 4x times x minus 4 over x minus 4. So now that these two things have the same denominator, I can add them together. I can add their numerators. So I'm just going to distribute into here 4x squared minus 16x. Okay, when I multiply all this by all that, all divided by just x minus 4 gives me one single rational equation, 4x squared plus, let's see, 64 minus 16 is 48 x all divided by x minus 4. Okay, so just in case you have a multiple choice test and this answer isn't on there, you need to know how to get down to here to make this as your equation. Okay? So let's see, 64. Let's make sure everything is on the up and up. No, it's not. Where did the 64 come from? I am so sorry. Let me erase all of these 64s. I'm sure you were just confused out of your mind as to where this 64 came from. And I just confused myself. 64 was a problem I was doing in class today. 30. So sorry. 30 over x minus 4. Much better. Okay, now we're all on the same page. 30 over x. There we go. 30, 30, 30. 16 minus 30 comes out to be 14. So sorry. I did not mean to confuse every single person with that. Where did the 64 come from? Yes, exactly. There's just anyway, here we go. 4x squared plus 14x over x minus 4. Okay, yes, even math teachers sometimes make mistakes when we have crazy things running through our brain. So this is the area as a function of just x. Okay, maybe I shouldn't have tried to simplify it. Anyway, that's besides the point. So now we need to go to part B. We have area equals 4x squared plus 14x over x minus 4. Now, what are the dimensions that will minimize the amount of paper used? So this is an area equation about the paper that we're using. So we're going to plug this equation into our calculator. So here's our handy-dandy calculator. Hopefully many of you have TI 84s. If not, this is a TI 84 that we'll be able to use here to figure this out. So we're going to plug this into our calculator, into y equals. Okay, if you have the latest operating system, we can put it in as an actual fraction looking thing. So 4x squared plus 14x divided by x minus 4. Okay, so let's just take a look at the graph and see what it looks like. There it goes. That's fantastic. Looks like we have a vertical asymptote at positive 4, as we should have when we solve your denominator. And I'm not seeing the other half of this graph. Okay, which means I need to adjust my window. So if you press the zoom button, we can go down and do a zoom fit. Okay, with something that the calculator has built in. And that will basically show us what our graph's supposed to look like. I mean, it may or may not be any better. In fact, there's our positive 4 asymptote, and then here is the rest of the graph right there. Okay, so this gives you a sense of, yes, there is a graph up there. Now we have to figure out exactly where that's going to be. So because I'm really just dealing with the first quadrant, I'm going to set my x minimum to 0. Let's do an x max of 20. Okay, with a scale of 5. Every 5 I'm going to have a tick mark. My minimum y value just 0. I don't think I need 1300 up there. Let's just go to 500 and see what happens. So setting the window is more or less trial and error. And you can have a pretty good idea of what's going on once you see it for a while. But that's a pretty good graph. Remember, this tick mark is 100, this tick mark is 200, 300, 400. So it didn't have to be this high. This is 5, 10, 15, and 20. These tick marks are all 5 units apart. So the most part, this is a pretty good graph. I guess I'm going to adjust it a little bit more so I can see more about where the minimum is. So I'm going to change my y maximum to 200 just so I can get a little bit better view of the graph. So remember now, this is 100 in the y value, this is still 5 in the x, this is 10 in the x, this is 15 in the x. So I'm looking for the dimensions that will minimize the amount of paper used. So somewhere in here is the minimum value, okay, the lowest y value on this graph. So I'm going to have my calculator help me and calculate that one. So second trace does a calculation. I'm going to try to find the minimum. Okay, so it wants me to give me a left bound. What's my leftmost point? And I'm thinking that this is pretty good. And then a right point, so I'm going to go to the right side of where I think that minimum value is. which pretty good in there. It gives me lots of space. Let's guess somewhere in the middle. How about that is a good guess? And then it will actually tell me exactly what my minimum value was. So when x is 9.47, I'm going to round up to 9.5 inches. That's going to be the width of my piece of paper that will give me the smallest paper possible to still have this 30 square inches of print. Okay, so x is 9.5, and what's our y value? Well, here we have an equation for the y value. Remember from our graph, we graphed x versus area. So this is an area equation. So my area would be 89.8. Not my y value, but my area, because the y value in this case is an area from our paper, or from our equation. We want an area of the paper. So this is the minimum area. In order to find the y value, I have to plug it into this equation, because this is the y value for any given x. So 30 divided by 9.5 minus 4 plus 4, that's going to be my y value, the other dimension of my paper. So let's go back to the calculator mode. We're going to do 30 divided by parentheses 9.5 minus 4, because I want it to divide by the difference, and add 4 inches to that. Gives me a y value of 9.454545. In other words, y value of just 9.5 also. So it turns out that the best piece of paper that I want to use to make sure that I have 30 square inches of print with a 2-inch square margin is going to be a square piece of paper that's 9.5 inches by 9.5 inches. Okay? Fantastic. See you again later.